Now we have to move with the pipe telescoping. I think it's a high time for tea, if it's ready. Okay. So what about pipe telescoping? So consider this, that we have 20,000 liter per hour, and we have to design a piping network for it. And after section 1, the flow rate, the outlet, at the first outlet, we lost 10,000 liter per hour. In section 2, we will have only 10,000 liter. In section 3, we'll have 6,000 liter, and in section 4, we have only 2,000 liter per hour. So now we have two possibilities. Number one is to use the same dia pipe. Like, based on my experience, I would say we have to use the 3-inch pipe. So one option is to use 3-inch pipe for the entire length. So it's okay, no need for the telescoping, and it's very simple. But being an engineer, we need not only to design the system, but we need to design an economical system. Because as Dr. Zia said, a fool who spends a lot of money is a good engineer. So it must not be like that. You must spend little money for higher output. So what we suggest, that we need to telescope that pipe. What does it mean? Like this. For example, we need to lower the diameter of the pipe, because 2-inch pipe is cheaper than 3-inch, 1.5 inch dia pipe is cheaper than 2 and 3-inch, and so on. So we need to utilize the pump, we need to install the pipe or design the pipe which is best appropriate. If 1-inch pipe can serve my purpose, why shall I go for 3 inches? The only thing will be that we will increasing the cost. Although it may decrease a little the operational cost, but the reduction in operation cost is very minimum. So we have to reduce the initial cost as well. And we must have a very good combination of the initial and the running cost of the system. So to economize the system, we need to do pipe telescoping. So what does it mean? In section 1, what we will see in section 1, we have, I would like, as I practice, I always start from the remote point. From the farmost point I started my designing. So in this section, in section 4, the flow rate is only 2,000 liter per hour. So based on the continuity law that we have mentioned in the first or second slides, that how to calculate the pipe size, you will have to put the velocity of 1.5 meter per second, the flow rate will be 2,000 liter per hour, so you will get the cross section area, and from that you will get the dia of the pipe. So based on my experience, I knew it, that it will be 1 nominal pipe size, yani 1 inch nominal pipe size dia. So for section 4, I will design 1 inch pipe size. Now in section 3, the flow rate is 6,000 liter. So again with that formula, I will determine what diameter is minimally required. So we for 6,000 liter, the requirement might be 1.4 inches, but as 1.4 is not available in the market, so we have to go for 1.5. In section 2, the flow is 10,000 liter per hour. So again, with the help of that formula, we will get what we will get. We will get 2 inch, and then with 20,000 liter, we will get 3 inch pipe. So that's how we do the telescoping, depending on the flow rate. To meet the requirement of that flow rate, we need to design the pipe. And why we do telescoping? Just to reduce the initial cost and not to increase the initial cost unnecessarily.